Don't bring the whole thing down, Pawan. He hits the button and it just.
Exciting. All right. That part we'll handle. So welcome everyone. Welcome to our meetup event, WTF is Data Engineering. My name is Pawan Nandakishore.
Don't bring the whole thing down, Pawan. He hits the button and it just. Oh, that's weird. What is that?
So that part we'll handle. So welcome everyone. Welcome to our meetup event, WTF is Data Engineering. My name is Pawan Nandakishore.
Don't bring the whole thing down, Pawan. He hits the button and it just. Oh, that's weird. What is that?
So that part we'll handle. So welcome everyone. Welcome to our meetup event, WTF is Data Engineering. My name is Pawan Nandakishore.
Don't bring the whole thing down, Pawan. He hits the button and it just. Oh, that's weird. What is that?
So that part we'll handle. So welcome everyone. Welcome to. What? Hello? Can you guys hear me?
Yep, we can hear you.
Something went wrong there. Can you guys see my screen?
Yes, we can see it.
Okay, let's do that over again. Okay, so welcome everyone. My name is Pawan Nandakishore. I'm a data scientist at Kolibri. I'm joined here with Joe Rice, who's the CEO of Ternary Data. And he's going to talk to us today about what the fuck is data engineering. So it's going to be exciting because Joe is an expert at this and he's going to educate us on all of this. So this is going to be a great learning experience. I'm also joined here by my co-host, Josh Hurst. Say hi, Josh, to everyone.
I'm afraid to say hi. Hi.
Thank you. So what's going to be exciting today is Joe's going to tell us, okay, everyone's training like all sorts of fancy machine learning models. They're doing all the cool stuff, but there's this whole issue of data and how to work with data actually. And you can't really do any machine learning training or anything fancy without actually understanding how data engineering works. So take it away, Joe. I think you are allowed to share screen, so you can go ahead. So let me.
Thanks.
Screen.
How's it going, everybody? Cool. Me too. All right. Well, thanks, Pawan. That was a nice intro, and thanks everybody for the Inception V3. That was awesome. So just get to my slides here. Yeah. So what the fuck is data engineering? That's a good question. I've recently been writing a book on data engineering, which we'll talk a bit more about. And this has actually prompted a lot of, I would say, interesting tangents. I don't mean that in a bad way, but the more you dig into what is data engineering, it's actually kind of an interesting topic. Why should you care? Well, if you're a data scientist, you need data upon which to do science. It's kind of how it is, right? But how do you get this data, right? And even if you get it, can you trust it? Is it of good quality? So really, do you feel like you have the data to do your job and build something great? So that's why you should care. As a show of hands, how many people feel like they run into challenges with just getting quality data that they can use for machine learning and so forth?
So people can just raise hands. All right, so that's good. 4, 5.
Cool.
6. Yeah, so we do see that a lot of people have this issue.
Okay, I'll extrapolate and think that's everybody. I'm just delusional. So what we're going to cover, we're going to talk about, what is data engineering? Who is a data engineer? This concept of the data engineering lifecycle. What are the undercurrents of data engineering, right? Maybe who a data engineer works with, some myths around data engineering, then we'll just do a Q&A. So. And obviously, if you have questions in the meantime, feel free to ask them. The thing I ask is avoid kind of bike shedding questions, if you know what I'm saying. So, Don't be that guy or girl. Who am I? I'm Joe. Kind of deserve this moniker that I made up called the recovering data scientist. I think I called myself that back in 2015 or 2016. And it was born, I think, so I've been working on data for quite a while. I started out doing a lot of forecasting optimization type problems. This is way back in the early 2000s. I was originally going to be an actuary, but then I got into, analytics, operations, that kind of stuff, operations research type problems. And along the way, I had a deep interest in machine learning. Obviously, in the 2000s, you really couldn't do much with that because computers were kind of crappy. And around 2012, I started working at an auto ML startup. So we were trying to do automated machine learning, give us a data set and we'll give you predictions. That forced me to start realizing that the problems with what would soon be data science, soon be called data science, were basically data engineering problems. I guess now it's called ML engineering, right? So getting your data, making sure it's good quality, productionizing models, all this stuff. I mean, this is stuff that back in the day we had no context of because we were trying to figure this out from scratch. So there's no playbook then, right? And so I've seen, along this time as well, big data came up and that, as a term, and I would say as, practice. So I've kind of seen the whole evolution of machine learning, data science, and so forth. Right now I'm a co-founder at Ternary Data. We're a data engineering consulting firm based in Salt Lake City. We have customers all over the world. We work with AWS, Google Cloud, Snowflake, you name it. We're probably working with them as a partner as well. So I also teach part-time at the University of Utah as an adjunct. Surprisingly enough, I don't have a graduate degree, so but I teach grad school. So there's that. And I also host a podcast, Monday Morning Data Chat, and the Data Nerd Herd. So those are two, I think, podcasts that are growing in popularity. I blog, and I'm also writing a book for O'Reilly called The Fundamentals of Data Engineering. So a lot of this talk is actually informed by the work I'm doing on this book right now. And like I said earlier, when we're talking about what the fuck is data engineering, I thought that this would be easy to answer when I started on this book. Lo and behold, it's actually more challenging than I think. And I would, so as we go through these slides and this talk, I understand this is coming from my perspective, kind of almost, live action role playing this, so to speak. So data engineering LARPing, I guess. So anyway, enough about me. Let's see. Sorry. Slides. Okay, sorry. Okay, so what the fuck is data engineering? Well, turns out there's actually a lot of definitions to this. If you Google, I just did this just an hour ago, type in an exact match for what is data engineering. I think you come back with like 87,000 results or something, which is kind of interesting. Here's a few that I found. Data engineering is the science of collecting and validating information such that data scientists can use it. Somebody else thinks that data engineering is all about the movement, manipulation, and management of data. I'll open this up to questions. What do you guys think data engineering means? And maybe type it in the comments. I can't actually read it right now because I'm looking at my slides, but if Pawan could maybe find
Yeah, I can read the definitions to you as
cool.
Put them up. Yeah.
Yeah, so if anyone wants to take a quick second and just type in what do you think data engineering means, we'd be glad to share about that. Maybe spend about 30 seconds to a minute on that. We can move on. So Paul, you have to read these out because I can't actually see them.
Yep. So
okay.
come on.
I can read these. Yeah. Okay. Yeah. I actually can read chat. Movement of data from master data ingestion and ETL pipelines, movement of data from source to target. That's awesome. Patty says moving the data around so it's available for data science and modeling. Cool. DE is data science.
DE is data science.
Well, then the next talk will be what the fuck is data science. So yeah, I think that these are all appropriate. So right, so that you got verbs, right? Moving data, right, from someplace to someplace else. Cleaning data, front end, back end, dead end. Yeah, maybe. So person who manages. What's that?
One point or one question I have is that so would you say that data engineering is relevant only to data science, or is it just relevant to an organization regardless of whether they're doing data science or not?
Well, let's talk about that. I'll get into this actually when we get into the history of kind of where this term came from. But I think to touch on this right now, it's actually, I think, spawned from quite a few roles that in the past, right? So in the 2000s, you had, and even before, like BI engineer, ETL developer, right? Data warehouse administrator, and so forth. Like all these jobs in practice are actually what modern, in the modern sense would be data engineering. Right. So, and I think the thing I'm also realizing as I study this subject in gory detail is like, what's old is new again. Like there's actually nothing new in data engineering. It's just a repackage, just like data science, frankly. Like that's actually just a repackaging of stuff that's been around for decades in some form or another. So cool. So my definition, and this is subject to change, but here's my definition as of today. So data engineering is the development, implementation, and maintenance of systems that take raw data and produce high quality and consistent information and support downstream use cases, such as analysis and machine learning. So you're moving data, you're making sure it's of quality, but it's really a practice, right? It's an engineering discipline. So if you look through the bodies of engineering disciplines, right, it's not just software engineering. You're talking about things like mechanical engineering. There's whole fields that, engineering's been around for a while. I would say actually, software and especially data engineering are relatively immature compared to stuff like mechanical engineering, for example, right? But if you approach it from first principles, engineering is really the development, implementation, maintenance of systems that do something, right? And so taking that a step further, that's my definition, as I say, as of today. Strangely enough, there's not a Wikipedia definition of data engineering. So there's that. If somebody's really bored and wants to do that after this talk, go for it. Otherwise, I'll go do it after the talk. So great. Yeah, so how did we get here, right? So the 2000s, you had and this is a lot of these titles before, actually, quite earlier, 80s and 90s, but you had, ETL developer, DBA, BI engineer, data warehouse administrator. I mean, I could argue that a lot of these titles are actually around even in maybe the 70s and 80s when you had Teradata come on the scene with, data warehouses and so forth. I had seen these terms, even in the late 90s. So these aren't new, but then they started evolving, right? Big data became a thing. You had big data engineers all of a sudden working on systems, working on Hadoop systems, later Spark around 2014 when that came on the scene, Spark developers and so forth. So you started seeing, it was a distributed computing really started driving this big data engineer, phenomenon. And a lot of companies started taking note of this. I would say I personally saw companies doing big data engineering on like a couple of gigs of data that would have probably been better in a relational database, but that's my opinion. So, but then the term data engineer, that started coming on the scene, right? And what also happened was data science, that was a career that took off. I would say data science as a phenomena that overtook data engineering by quite a big margin. Like there was a sexiest job of the 21st century, and so forth, right? Data engineering was basically, they didn't really hear a lot about this. I got into it probably 2014, I think, is when I got, into, I would say when I started using the term data engineer to refer to what I was doing. I felt it was more accurate than data scientist. But again, these were all terms, right? But it's good to get this out of the way. And now in the 2020s, you're starting to see, and this was actually before in late 2010s, so analytics engineer, that was a new title. I consider that sort of a subset of data engineering, or maybe sort of a synonym in some respects, but ML engineering, that's another one. In the last several years, that's popped up as a, I think a very popular title and a highly paid one at that. So, and traditionally though, these were sort of roles that the data scientists would be doing, right? So you always hear these stats, like data scientists spend 80-90% of their time gathering and cleaning and processing data, and only, a small amount of their time actually doing data science work. So that'd be machine learning or getting insight from the data. Really, that's the work that a data engineer should be doing. I think what happened was companies would hire these data scientists because they're this magical unicorns that would solve all the problems in business and generate, endless amounts of money and value. And what ends up happening is, the data scientists spend their time building the systems to get the data. I've seen this countless times. So anyway, so then, data engineer starts standing out on his own. I think is what we were starting to see then. How many people have seen this data science hierarchy of needs slide? Anybody?
I have seen this multiple
Yeah.
times. This is one
Nice.
of the
Yeah.
important ones.
Yeah. Sort of the canonical slide, right? So, everyone wants to do the top of the pyramid. A lot of people just start trying to do the top of the pyramid, and a lot of people end up kind of dying at the top of the pyramid without having much success because they haven't built the foundation. So Monica Rigardi, she made this, she wrote this article, I think in 2017 or 2018. And, for me, it really resonated, right? Like the foundation is something I saw a lot of companies skip. And so, my mission was, to start a company around helping companies build this foundation. Whereas I like to do machine learning up here. I just felt that it wasn't, for me personally, the kind of thing that I want to focus my attention on without helping people build, the bottom two layers, especially. So, yeah, feel free to ask questions as well. So data engineers, they focus on the collecting and moving and storing, maybe some transformations of data. And we'll talk more about this. I think that as abstraction starts occurring in the tooling landscape, especially, you're going to start seeing data scientists move up the chain here. So up the pyramid. So what is a data engineer? Well, okay, that's great. Kind of answered it already, but a data engineer applies the discipline of data engineering, and they take raw data and they make it useful for downstream users. That's basically it. Notice I'm not talking about any particular tool sets. We'll talk about this in some of the myths later about data engineering. Like some people say data engineering is Spark. Some people say data engineering is, this, that, or the other tool or whatever. I don't think that's the case anymore. I think maybe for a year you could self-identify as a data engineer if you're working in these tool sets. I think that boundary has become a lot less defined as tools have become more abstracted and it's easy to use, right? So what does a data engineer do? Well, I mean, they get data, they make it useful, and they serve it to downstream users. That's pretty much it. So
I think it's a simple definition, but there's so much involved in that, right? Like,
yeah.
what is useful data?
This is right. Exactly. That's a very valuable linchpin of a word there, right? So
yeah, I mean, that's something to think about for the audience, right? Like when you think about data, right? Like how do you classify something as useful and not useful, and how do you build build pipelines for useful data? That's something to think about, So yeah.
I mean, I would say that the counter argument is like, okay, so I'm going to okay, so are you going to make data that's not useful?
Yeah.
I want to make a useless data pipeline. I serve nothing but like the crappiest data to my downstream users. I mean, I'm sure this happens actually quite often, but as a practice, right? If we're trying to consolidate on something a data engineer does, this is sort of a framework. But to your point, it's overly simplistic, and this is for a reason, because the devil's in the details. So this is traditionally a data lifecycle. This comes from data lifecycle. This comes from HBR. It's funny, as an exercise sometime, go and Google data lifecycle. You're going to come across countless slides, frameworks for data lifecycle. I like this one in particular though, because it seems holistic. It's quasi benign, and you can get some value out of it, right? So you can generate data, collect it, process it, store it, manage it, analyze it, maybe visualize it, maybe interpret it. I think that what's missing from here is obviously doing something else, which is machine learning, for example, automations and so forth. But that's besides the point. Just understand data does have a life cycle, it has a flow. This is what a data engineer, as I started thinking about it more, a data engineer really is a lifecycle manager at the end of the day, right? So with respect to the data engineering lifecycle, again, this is still a work in progress, but I think, if you look at the areas that the data engineer focuses on in particular, it's getting raw data from source systems. It's designing and maintaining the data engineering systems and processes like we just described earlier when we talk about engineering, right? And then it's creating data models. It may not necessarily be a machine learning model, but it's data that is modeled for consumption by data scientists and analytics or analysts. And so this means, this is the useful part here, right? The data engineer needs to make data models that are useful for the downstream customers. It would make no sense to make data that is not consumable. So some data scientists, of course, go to the raw data, and that's perfectly fine. But again, I could make an argument that even if it's the raw data still needs to be in a state where the data engineer has ensured quality, reliability of access, and so forth. And so the data engineer, and some of these, pieces might be chained together and they might be rechained together, right? And so at which part of the life cycle is R programming at? I think it depends on what you're using R for. If you're using it for transforming data, it might be in the middle here. Maybe creating the data models, or at the end at the data science and analytics. It totally depends on, I think it depends on the use case, and it also depends on your definition of what is useful, right? So useful data. Paul, pick up on this one. So let's just read this question real quick. The question for people who are watching this and not able to read the questions, Ashton asks, is it up to a data engineer to be completely familiar with the business logic while working on projects, or would this require collaborating with a business analyst who might be more familiar with the business logic and needs? I struggle with this. I think my tendency is to think that a data engineer, it depends a lot on the type of company you're working at, right? And the size and the maturity and so forth. If your company is mature, is data mature, and they have specialists, I would say that the need, you should still understand business logic. And I'll get into this in a second, sort of the undercurrents part. But I think if you're at a startup, for example, say you're a data engineer one, you're going to have to know the business logic, because you're going to have to know what's useful for your downstream users. It's as simple as that. And I don't know. I'm always a fan of understanding business logic, though, because I think that unless you, as an engineer, know the business logic, it's just you're at a pretty big disadvantage, right? So, but that's me.
One other point, Joe, would be that it would depend on whether you're on a startup or an enterprise as far as data engineering is concerned, right? The kind of work you do would be very, very different.
Very much so. In my book, I talk about, there was an interesting article actually that came out from somebody at Twitter a few years ago. They talked about type A and type B data scientists, right? So type A data scientist is more kind of your analyst, right? Like they're not really building, new models or any of that kind of stuff. Type B is the builder. There's an equivalence in data engineering, I think, where you have the type A that's really maybe just bolting together systems, like your 5-trans snowflakes, and it's incredibly easy to do this. Your type B data engineer, though, is the one who's building new systems that are, hopefully going to give your company a competitive advantage, right? And so, but this also assumes that you're at the stage where you need to hire somebody like that. I think to your point, Google does this, right? Because they're very unique in the universe, and they hire engineers to solve pretty tough problems and so forth. But if you go to like more pedestrian type companies, mature legacy, I don't think that's not all data engineers are going to be doing the same kind of work.
Yeah.
So Patty says traditional DBA doesn't need to know the business. Yes, for this seems like need to understand business, since you need to know what data to bring in. Yep, I think that's right. So the source systems management part, right? You got to know the data coming up from source systems. If you don't know that, I don't know how you can do your job. It's that easy. So it would be like being a chef, but like not really understanding what you're using for ingredients.
Yeah,
it would be really, I wouldn't go to that restaurant. Undercurrents. There are, so across this workflow, wherever that was. Sorry. So across this life cycle here, data engineering life cycle, there's also, sorry, my slides are going bananas. Here's some things I've identified so far. This isn't complete yet, but what I'm identifying is there are certain disciplines that undercut everything in data engineering. I would say that a lot of this, there's some things that undercut other things, maybe ML ops to some degree, or maybe ML engineering, maybe data science, right? So data governance, for example, making your discoverability, security, and accountability of data. There's a lot to unpack with all this. You get into stuff like metadata, master data management, all these things that used to be very, I would say, enterprisey, like stuff that was straight out of Office Space, big corporation stuff. Like this is now trickling down into data engineering, and we'll get into why in a second. Data modeling, made security twice. It's that important. Data system design and so forth. Data management is a pretty big subject. I mean, I got this book here, the Data Management Book of Knowledge. This thing is like almost 600 pages, or like the driest material on earth, written from like the most enterprisey people on the planet. And this book is awesome, by the way. I love it. Why do I like it so much? Because like I hit on earlier, there's a lot of stuff I think that's being recycled right now. And there's this theme where like what's old is new again, right? So if you look at stuff like data ops here, like it's just basically DevOps applied to data. Some of these are technical aspects, automation, monitoring, observability, but then some stuff is cultural, like incident response, right? So how are you going to respond to incidents? Do you have a culture of DevOps or data ops, right? So this is organizational practice. I would say this isn't really skewed towards technology per se, although technology enables data ops. But these are things you got to keep in mind, right? It's not just, oh, I'm going to spin up my Spark cluster and that's it. Like those days I think are gone. You got to think of all these different aspects now. Data architecture. You want to think of what makes good data architecture. It's nothing more than just understanding what are the trade-offs in my decisions. Neil Ford, who works at ThoughtWorks, he has a really good book on software architecture. And one of the things he says is, good architecture is not Googleable or something like that. You can't Google good architecture, because by definition, the architecture you're designing is specific to your use case. And so you have to understand the trade-offs that add value to the business, as well as, that's designed for agility and flexibility, because things are going to be changing so fast, especially in the data world right now. I mean, if you do machine learning, I mean, you'll need, no need to remind you how quickly things change. Seems like every second.
Yeah. And there are new types of problems, new types of tools that are coming in, and you have to integrate all of that into it. So one question maybe that might be beneficial for the audience is, how does like one go about learning how to do good data architecture, to build good data architecture?
What was that, a question for the audience or for?
Oh no, I was aiming at that towards you.
Okay.
What would your recommendation be? Like, how do they go about learning that?
So, I mean, there's the things you have to know, right? So it's like, how do the everyday systems work? How do I, if you're doing software engineering, like how do I code these in such a way that it's going to make sense? These are, sort of baseline. What are the technologies I'm using? How do they work? Hopefully at an atomic level. I'm very much a first principles person, so I tend to go deep into things. But then you also need to have the breadth and understand, okay, so how do these pieces fit together, right? Both for the system I'm designing, as well as systems it's going to interface with. And so, and then domains, right? You need to understand, there's a, the principles like domain-driven design, which is a very popular software architecture framework from the early 2000s, right? So what are the contexts that I'm designing for? Yeah. These are all things, right? And then maybe taking a step back, understanding, okay, enterprise architecture. This sounds incredibly lame and boring, but you should probably understand what that is too. Yep. And unfortunately, there's like a million frameworks to understand enterprise architecture. So I would say just read a lot about architecture. There's not really, and then practice it. Think about the systems you're building. But it's almost, I would say the thought process is almost orthogonal to what you'd be doing as an individual contributor, for example, whether you're a data scientist, a data engineer, or whatever, because it's night, instead of going deep on solving a specific problem, you have to think in terms of systems and how they interrelate. And it's a much different thought process.
Yep.
And depending on the company you're at, I would say, you know, they might have data architects that just do this. But I think a data engineer really does need to understand the trade-offs of their decisions. And you know, an increasingly, I would say confusing world of data tools, it's especially important to understand, okay, so there might be a million tools, but like what's the underlying principles of where these tools would fit in, for example, right? Do I understand storage? Do I understand how ingestion works? It makes it a lot easier to evaluate. I mean, I'm looking at tools, all new tools all the time. I mean, it's blinding, but that's my job. I have to, right? So, oh yeah, and the other undercurrent I think is software engineering. There will be times when you have to write production grade code because you're making production systems. So just understand programming, coding skills. I know it's incredibly vague, but if you're writing in Python, for example, at a minimum, understand like PEP 8 and use that, the standards for Python. Understand how object-oriented programming works, how functional programming works in Python, same with Java, whatever other languages. Understand software design patterns. There's a bunch of these out there. I think Martin Fowler's blog is a great place to learn software design patterns. Learn testing and debugging, and there's probably a bunch of other stuff I left off here, but these are sort of the undercurrents that I see in data engineering that just underpin every part of the life cycle. You have to consider these things. So any questions? Cool. The data engineer, right? So upstream, they work with software engineers, application developers, product managers, project managers, DBAs, et cetera, et cetera, et cetera. Basically people who are working in the source systems that are providing data that the data engineer is going to use and provide for downstream consumption. Downstream, those people are going to be analysts, data scientists, ML engineers, ML ops, and so forth, and whatever other titles come about in the next year that I have missed out. So, and then also, the business, right? This is always in quotation marks. You got to understand the business. I was fortunate to straddle, I would say, the business in a lot of my roles, and so maybe I have a unique empathy for the business, but at the end of the day, the business just wants things done at value. So, executive stakeholders for certain projects, et cetera. This is also where domain-driven design comes in, right? If you're designing systems for a particular domain, typically that's going to be a business domain with stakeholders of the business. So you need to understand, and this comes back to business logic. Probably want to know these things. Your stakeholders would feel really good if you knew this. Alberto, he asks, where do you trace the line between activities, roles, and teams? That's a good question. I think it depends on the type of company you're at. I don't know if there's a standard answer for this, which is great, actually, because I think it really just depends on how you've structured the roles and the teams and what they're working on. I will say one thing to keep in mind. There's a law that I bring up often. It's called Conway's Law. So Conway's Law describes basically a company will design communication systems according to the way the people in the company communicate, right, and how it's organized. So if you're really siloed, you're going to get siloed systems, and that's how it is. So I think that's one piece that I would keep in mind. There's a lot of stuff I think to unpack with that answer, Alberto. It's a good question.
So basically you're saying that it also depends on the culture of the company, right? Like if you have a fairly, interactive culture, then things will just, your systems are going to also reflect that in some way or the other, right?
Yeah.
Versus siloed culture, it's a different thing. Yeah.
For sure. Yeah. It's I would say that company size is one aspect of it, but I've seen small companies, though, I would say, that were very data mature, and I've seen large companies that are very data immature. So company size is one attribute, but I don't know that that's like the only criteria. It certainly helps, and it would certainly, I would say, influence the ability to fund data projects, but it assumes that the company is ready to do data. I mean, I've worked with billion-dollar companies that weren't doing any data. Actually, they barely had reports. You know, whereas I've, you know, some of my clients are like 5-person startups and they have it together with data. It's crazy. So just I think it really depends. Do we get a copy of the slides, please? Yes, you do. Sorry. So yeah, and you know, and the, you know, when I'm thinking about this, I do think about the data maturity of a company quite a bit. It has nothing to do with size. I don't think it has more to do with, I think, the organizational willpower to utilize data fully. Like I said, I've just seen too many counterexamples in both ends of the spectrum to think it's, you know, it's a very linear relationship between as you grow, you become more data. In fact, as you grow, it actually might be harder if you haven't done these things. It's you have so much institutional inertia built against you, against doing any data stuff. This is actually where I've seen a lot of data projects fail, is not early on in small companies. It's actually in the bigger ones where there's just there's a competition for resources, and just gets kind of gnarly. So yeah.
I suppose as a company grows, the data becomes so large that if you don't have these systems put in place early on, then you just cannot handle it, right?
For sure. Yeah, or you don't know where it is, right? You don't even know what you have, which is why data management is a big thing. I'm gonna, you know, I hit on where it's these old school things, data cataloging, data dictionaries. It's almost as boring as telling people to go floss their teeth. Actually worse, I would say. Like, but there's now a recognition that because you're not doing this kind of stuff, or if you haven't, like, nothing's free in this world. That accumulates debt over here that you're going to have to pay back at some point, or you ignore it at your own peril, I would say. So a lot of these boring topics and areas are now, I think, suddenly seeing a big, there's a lot of interest for that reason. Because yeah, as you accumulate more data, that's great. Except you also got to use it and know where it is. And now there's compliance, right? So if you need to, you know, depending where your company's operating, you know, if you get a deletion request, you need to know where that data resides, right? So yeah, let's see here. Data engineering myths. Okay, so this is actually from a talk I did in India a few months ago. We just talked about myths. So I got 5 of them, something like that. These are myths I see quite often still on social media, especially because that's, well, you would expect to see myths of all sorts on social media, not just about data engineering. So myth 1, data science is better than data engineering, or data engineering is better than data science. I don't really have a dog in this fight. I think they're both important. So, but you see this one, you see a lot of these posts like, well, you know, data engineers are okay, but data scientists are like super cool. And the reverse argument, you see this a lot on LinkedIn. Actually, there's a lot of hilarious posts on LinkedIn. I'm not on Twitter. I'm sure the same thing happens there, but they're both important when they're, I think, working in harmony. You do get contention on teams though, where data scientists, I think, do have, you know, there might be some tension between the data engineering team and data scientists and vice versa. So this is, again, this comes back to cultural issues. So, but I see this argument over and over. So this is one I bring up often. What's another one? Data engineering is a big data tool like Hadoop and Spark. This, like I pointed out earlier, this may have been the case. Maybe I can make a strong argument against why not, but let's go with it. Let's say this, you know, you were a data engineer if you're using Spark. I just think it's changed. The tooling landscape has changed to the point where there used to be a lot of machismo, I would say, back in the day with like, yeah, well, you know, I'm a Hadoop engineer, right? And anyone I know who's using Hadoop is like leaving Hadoop right now and going towards something a lot simpler.
Yeah.
So,
most data engineer jobs require several years of experience. How do I land a data engineer job with less than 1 year of experience?
It might be one of those situations where if you're working at a company, you might be able to sort of segue into a position as well. You get to know the data engineering team and just get on board it that way. Because yeah, I mean, this is a good question, which is also kind of a funny question in some ways, because it it's like the job descriptions where it's like you have to have like 20 years of Spark experience. So I, I would maybe dig beneath the covers and just maybe also ask the hiring manager, like, how much experience do you actually need for this job? Like, what are you really looking for? Because a lot of these job descriptions, depending on the company, obviously, there's some pretty terrible job descriptions, and there's some pretty great ones. I would say the great ones are like to the point. There's not a lot there because they just know exactly what they want. They're not going to like fill it up with like, you need like 20 years of Spark experience, like 50 years of Hadoop experience, and you got to know, Python and Node and React and deep learning. So.
Hey, I've seen job descriptions with 10 years of TensorFlow experience. Those are fun.
That's awesome. Yes, it's a good question. I mean, I also have some videos on my channel where we talk about making a data engineering portfolio. That might be something you want to do too. I think if you're starting out and don't have a lot of experience, just showing people your enthusiasm, your projects, all that kind of stuff is worth your time. Portfolios are kind of weird, and data engineering portfolios are weird because it's like showing off like the plumbing you built at a house. It's like, well, I can take pictures of it, but I can't really like rip the walls out and show you what I did, right? So you got to keep in mind it's very like so I'd maybe make a video, show people that kind of stuff. But I have a video that shows that. So
yeah,
so
one example I've seen is there's this person who took like all their Strava data and just built like a pipeline and just built a dashboard.
Oh, yeah.
You can do these sorts of interesting projects where like either data about yourself or some other news data or something like that, and just build pipelines and show that, hey, look, I can move data from raw data to process it to something else, right?
Yeah.
So.
And that kind of stuff's awesome. Like if I saw somebody doing a project like that, I would, buy them a cup of coffee and just ask them about it. Like that's really cool because it shows, a level of just a level of enthusiasm, really. Like I like to work with people that are enthusiastic about data. And in fact, one of my recent hires, I don't think she had much experience with data engineering, but what I realized is I think a lot of these concepts can be taught, right? The thing that really can't be taught is, okay, are you able to continuously learn, for example, right? That's either kind of do that or you don't. Are you enthusiastic enough to keep learning? That you either have that or you don't, I think, right? But learning, data pipelines, I mean, that's, if you have an enthusiasm to learn, I think that everything else falls into place. So side tangent there, but let me see, myth. Oops, sorry. If a FANG company does something, I should do it too. So we see this a lot in the data space in general. Google, Netflix, Uber. They all got great blogs. A lot of them have great projects. And here's the deal: a lot of these companies have built these systems because they had to build them this way. It's not like they. So I was talking to this guy. He worked at Hadoop at Yahoo back in 2003. So it was distributed systems PhD, and they had this classic problem of, well, we have a lot of data. We need to do something with it. So a distributed engineering background. He figured out on a team helped figure out ways to to make sense of this data, and I think that later became what turned into Hadoop, but then he later went to Facebook and wrote Hive for very much similar reason. It's like started out with a small amount of data, these Oracle databases, had to figure out how do you distribute data amongst all these data centers at the rate the Facebook data was probably growing in 2008 2009, right? Scaling it from like basically some Oracle databases all the way to like hundreds of petabytes in a few years time. Like that's a unique problem that maybe most companies don't have, right? Yeah. And so you got to take a step back and say, okay, so understand the context. When you read these white papers from Google, they're awesome, but they're also for Google. Like I was climbing the other day, my friend, he's a developer advocate at Google Cloud, and it's like, so tell me about some interesting parts of your job. And he's like, well, he goes into companies, talks about Google Cloud and the benefits of it, but he's like, you got to understand, like, what we develop at Google is unique to us, right? We have a petabit scale network that spans the globe. Like you probably don't need this if you're, just get started, right? But you can buy it from or rent it from us. That's cool. So let me see here.
This is actually a problem in general, like even for learning models, right? When Google or Facebook build something at that scale, right? Because they have the data to do it, right? Like as even medium-sized organizations just don't have that kind of data. They haven't collected that data, and they don't have the appropriate systems to really go out there and do something fancy with it, right? So rather than sort of trying to mimic them, the idea would be that what can we build that's unique to our use case and that helps our business grow?
Yeah,
right? That has to be the important thing. So we do have a question.
Yeah.
Mark
Freeman, what's up, man? I know this guy.
How do tools such as Fivetran and Stitch fit within data engineers workflow? Should a company still growing in data culture maturity hire a data engineer first, or go with one of the above vendors to get by for the time being?
I would say, maybe it's a mix of both. Depends on what you're trying to do. Full disclosure, I partner with Fivetran, but it's not without a good reason. I think that a lot of, so a few years ago, me and my friends, we started using this term undifferentiated heavy lifting, right? So stuff like pipelining data from point A to B, that's very much a solved problem. There's a lot of companies out there that do this. There's Fivetran, there's RudderStack, there's many others, right? Airbyte, they just came out, raised a bunch of money, and so I would say figure out the off-the-shelf tools that solve most of your problems and focus, so it's a Pareto rule, right? So figure out the tools that are going to solve most of your problems and focus your energy on the 20% of activity is going to solve 80% of the value, right? So I don't think, so I can make an argument it's both, or one or the other. I don't know. It depends on what you're trying to do. So, but I think to your point with data culture maturity as well, that's a tough one. I need to think about that. But I would say as a general rule, we'll talk more about this, like just avoid undifferentiated heavy lifting if at all possible. And just go with either open source things to do this or, buy it. So data engineering is only for big companies. This was something I used to hear a lot. I think it's becoming increasingly, well, it kind of fits in with Mark's question, actually. So there's a data maturity aspect to this. And as we saw, like data mature startups, for example, right? Data native, digital native, it was actually easier for them to do data engineering because they didn't have a lot of institutional baggage in the way. So I would say this is kind of, data engineering is for all companies. So is data science. I'm trained as a data scientist. Data engineering is not for me. That's totally untrue. You can become a data engineer and still be a data scientist. And I would actually hear this argument from people too. Like a data scientist or an analyst can't be a data engineer, right? Because there's too much software engineering involved. It's way too hard for you. You won't be able to figure it out. Just stick with data science. I mean, it was almost this condescending kind of mansplaining thing. Actually irritated the shit out of me. So it's not true. You can become a data engineer if you want. I know plenty of data scientists who have become data engineers. I know data engineers have become data scientists. It's a free world. There's a lot of great knowledge out there that you can go find. I would say it's easier to learn how to be a data scientist than a data engineer simply because there's not as much information about data engineering right now. I think that's changing. I'm doing podcasts, writing a book, writing articles. Seattle data guy, shout out to him. Andreas Kretz, and people like that, I think are doing a great job at coming up with content. Jesse Anderson as well. He was leading the charge way back in the day, but a lot of good content, and it's only growing. So yes, you can become, if you're a data scientist, you can become a data engineer if you want. Okay, great. Current trends, kind of rounding this out here. In data engineering, it's definitely maturing as a field. Again, I don't think this was actually a job title, several years ago. But then again, data scientist wasn't a job title either. I think data science came out in its modern incarnation, I think 2009 with DJ Patil's article, right? So, and he intentionally left that. And I think in a later interview I read, he actually said data science was supposed to be vague. There wasn't actually a definition for it. So Other trends, well, so the same things with data engineering. I think it just kind of sprung up. You have data, you're doing data, you're doing engineering on it. So we'll just call it data engineering. There's a movement towards cloud first. Historically, there was a lot of on-prem activity, especially with Hadoop, but that's changing. And so actually Cloudera, one of the kind of the companies from the old guard of Hadoop systems, I think they just announced they got bought by a PE firm today. So see what happens with that. Best of luck to them. Great people. But yeah, the cloud, it's kind of where data engineering is happening. I think that there's, it's at least where you should get started. I know Andreessen Horowitz had an article recently on the sort of the economics of cloud at a certain point, and maybe it's more to your advantage to, go on-prem, but that's an argument for a different day. But it's all about cloud now: GCP, AWS, Azure, and I could make an argument Snowflake is its own cloud, or it soon will be. They call themselves a data cloud. So,
yeah.
Sorry. Moving from big data to just data. I tend to think big data was could be a nice. It was a nice way of describing what was going on. I think in the early 2010s, especially, but those days are gone because you're seeing the same systems that you can use on small amounts of data. In the class I teach, we use BigQuery. And I mean, some data sets are like a few kilobytes, but BigQuery can also be used for like mega petabyte scale data, right? So, I just don't see there's much of a difference anymore. It's good marketing speak though. So, X as code, so infrastructure as code, analytics as code. This is happening now. You got DBT, Airflow for orchestration. You got great expectations for data quality. These are all plug and play modules, and like the list is endless, which we'll talk about in a second. And to Mark's question earlier, right? So, I think data tools are becoming largely plug and play. You're starting to see Fivetran's a good example, Snowflake, BigQuery, and then new ones just came on the scene. Firebolt, Upsolver. Upsolver is particularly interesting. They came onto the scene to basically as like a simpler version of Databricks, right? So I don't even need to know Spark anymore. I can just put my data into a data lake or a data lake house and do my thing. So, and there's a lot of data tools. In fact, the data landscape is growing. This is 2012. I was around at this time. I was like, wow, there's a lot of data tools. How would you ever keep up on things? Well, good thing I didn't ask the guy in 2020 that question. I think this list is actually abbreviated as well. Because when I look at some of the logos on here, I think it's intentionally supposed to be this absurd looking where you just can't read it. But as I look at this, I can think of quite a few areas where there's you could insert more, but this is only growing. Now, of course, there might be consolidation of tools at some point. I mean, that's kind of what happens. But I feel like the data space is still immature enough where that's perhaps a long ways off still, if it ever happens. What does the future of data engineering look like? I actually have no idea, but I'll take some guesses here. So higher levels of abstraction, right? So again, we have all these tools, plug and play. It's going to be a bigger theme, which also means, you're not going to be doing as much low level engineering except where it counts. And I think this is great because what this means is data engineers are going to start adding more value up the food chain, so to speak. So getting back to the boring stuff, right? Data lifecycle management, data governance, all the stuff that was like cringeworthy several years ago. I remember people were cringing at these actually. This is like the most boring stuff ever. I just want to write Spark jobs and, be cool. Well, this is the new cool stuff, enterprise data engineering. I just had a little blurb about that on Seattle Data Guys blog. It's something I came up with, but I think enterprise data engineering is going to be the new cool thing. What's old is new again, right? I mean, this is stuff that was once reserved for conferences, stodgy conferences with like really bad food and blue shirts and khakis, and it's coming back. It's already happening. Data quality libraries getting funding. That's cool. I think that's awesome. And also closer collaboration with software engineers, ML engineers, and other titles yet to be invented, right? So I think as you start moving up the higher levels of abstraction, you're not going to be so siloed, putting out fires with your particular stack, your monolith. Like everything's going to be integrated. I have this wild idea that someday actually software engineers, ML engineers, and data engineers might actually be kind of the same thing. Some people dispute me on this. I would say a good counter example to look at is Google's Firebase. It already has everything in it. You can pipe your application, talks to BigQuery, and it has machine learning built in out of the box. I think it's a preview of things to come. I think a lot of these lines are going to be pretty blurry in the future. But again, this is my guess, and it's a guess. So, and then any questions?
Yep, I'm sure there's going to be questions. So I can start off with one question. So you would have obviously heard of MLOps, right?
Yeah.
So what is MLOps compared to data engineering? Are they the same thing? Are they different?
It's interesting. I was talking to somebody about this today, actually. It's the AI Infra Alliance. We're going over like a kind of architectural diagrams of like what would an ML stack look like. I think that there are definitely some distinctions, right? So an ML engineer, an ML ops, I mean, it's primarily focused on maybe the machine learning lifecycle. The data engineer, I think, is more focused on sort of the earlier stages, right? Just getting data, ingesting it into something that could be useful for either a machine learning workflow or analytics. But again, as I think about especially data ops versus ML ops, right? There actually isn't that much of a distinction as far as I can tell. There's details, and that one is dealt with machine learning, the other's data, and there's DevOps, but yeah, it's so, like like a feature store, for example, right? Does a data engineer need to know about this? I make an argument they do, actually.
Yep.
So, but again, it's interesting because a lot of these are fairly new concepts, new-ish concepts or recycled concepts. Like feature store wasn't even, people weren't talking about that a couple of years ago. Now everyone talks about feature stores. Metadata is another one, right? But that has intersections between ML ops engineering and data engineering. And I was talking to a guy the other day about metadata first architecture, and I could see an argument where that actually transcends both the data and the ML. Because like, why do you have, if you have metadata about your processes and data and so forth, like, why do you have to have these artificial distinctions between machine learning and data pipelines when really it's sort of all the same thing at the end of the day, at least as far as I can tell. So I don't know, what's your thoughts?
No, I mean that makes sense. I think ultimately without data there is no machine learning, right? Like you can't really do any machine learning, right? Ultimately, so you need to understand. I think over time it probably will be absorbed into data engineering as a discipline. It will be like one subset of it that requires understanding like how data works in order for you to be able to build and maintain models and whatnot, right?
Right.
So it's to me it's like this. I feel it's still like a buzzword that's just come out. Like it's one of those things that just keeps happening with machine learning and data science in general. Like there's like whole set of these buzzwords that just keep coming up, right? So we have another question. What do you think are the first areas for a data scientist to learn more skills for data engineering?
I think to answer that, it depends on the type of company you're working at and what the needs would be. So it comes back to data maturity of a company. And so if you're at I would say a data immature company, you're probably going to need to know, how would you architect a system and maintain a system that spans the entire data engineering lifecycle, like we described, right? So storage, like ingest, storage, processing, and so forth, serving. But if you move into a more, if you're working at a more data mature company, maybe you're focusing on one aspect of that pipeline. Yep. And so I think it depends, but then within that that section or pipeline, I think that would be a sort of a rubric to figure out where to focus your learning. Now, in terms of particulars of what you should learn, oh man, remember that slide I showed you with all the data tools?
Yep.
Yeah, that's hard. I'm thinking a lot about this as I write my book. Actually, I think so a really good book actually is what is it? Let's find it here. Designing data intensive applications. This book came out in 2017. I still think it's one of the best books written on data engineering, period. Incidentally, this is like the top 2 most selling O'Reilly book of all time. Riveting title, as you can tell, like it just flies off the shelf, but it flew off the shelf. People bought this thing. And so I think it still holds weight after all these years. It's almost 600 pages, so you can breeze through this in like a day. Just kidding. What other questions we got here?
So we got quite a few questions. Any recommendation for data protection software and platforms?
Well, I guess I need to ask what data protection means. So
I guess you have frameworks for data privacy, data protection. Well, would that really come under? Yeah, that does come under data engineering, but would traditional sort of data protection tools make sense in this context? Yeah, I don't know.
So Ian, if you could clarify what you mean by data protection, that might be helpful. But I'll take a stab at this because I think it falls under the for security. It really depends, I think, on where you're architecting your data systems, right? So if you're in the cloud, I'm going to use a cloud as an example because that's normally where I work. So maybe in GCP, for example, just making sure simple stuff like IAM roles and everything are set up properly. People have like principal least privilege, right? So people are only granted the permissions they need to do their job and no more. And when they don't need them, they get taken away. So that's like, I would say if you're taking like a cloud architect exam, for example, this is like the first thing they hit on. It's like security and permissioning, because it's like this is where people like really fuck up, honestly. Like leave EC2 bucket or leave S3 buckets like open to the public when they didn't mean to, or leave like ports on servers open. So I would say just basic understanding of like these types of things, network security, VPC security, that kind of stuff. If you have to set up maybe a VPN between your cloud and your on-prem, how do you do that? So just understanding, that kind of stuff, encryption. Now, as far as tools go, there are definitely tools out there. DPS, I think, is what Google has, data protection service, and but really, I would say there's good tool, and that there's data cataloging as well. Like I think they have the data catalog tool and Dataplex they just announced, which is kind of like a data governance tool, so you can kind of see a lineage and all that stuff, which I think is a part of data protection as well. Yeah. But just understanding how things work. What used to be called Stackdriver and GCP and is CloudWatch and AWS, like understanding metrics related to that and like security and logging, for example. So understanding what your users are doing and those kind of things, I would say, are things I would look at. I know I didn't answer the question of tools per se, but I never view security as a tool discussion, because I think when you start looking at, if you get too focused on tools, you sacrifice, security is very much a behavioral thing, right? So that's how I view it.
Culture thing within an organization. How much do they emphasize on making sure that like, do you have two-factor authentication for everything that you're doing? Do you have
bingo?
OAuth and whatever tools are required, right? Or whatever methods are required to ensure that your data is data.
Yeah, here's a big one too. Like, what is it that the meatpacking company that was shut down today because of a ransomware attack, right? I don't know how that ransomware got into their system, but I think it's something, I might be wrong in this, but I think that pipeline ransomware attack a few weeks ago, that was like a phishing attack. Like somebody just clicked on an email, and so I at that point, like no amount of then you had SolarWinds too, like that. Yeah. That was so no amount of sophistication is going to help you if like your weakest link of your vulnerability is somebody opening an email, right? So DBA normally does security. Yeah. It's
don't set your passwords to password 123.
I remember like this password reminder. It was It was rhymes with ass word, I think. That was his password. So that's that secure. What other questions we got here? I think Alberto, do you think that data governance will be a priority for the data engineering discipline in the future? It totally, I 100% do. Data governance is a fascinating subject. I know that sound like I'm overselling it, but it's interesting. There's a lot of nuance to it, but data discovery, security, I would say, is part of this with the stuff we we're just discussing. Like, so yeah, data governance, it should have been part of data engineering all along. I think it just got overlooked because people were working on other stuff. But yeah, in some ways, I think data governance and data engineering is, you got to be engineering for governance for a lot of reasons, not to mention just pure compliance reasons. So you got GDPR, CCPA, and Lord knows what else is coming down the pipe, plus new EU AI legislation, which is going to be a boatload of fun for people. So yeah, I definitely say that's important. Sorry, what's up?
One question that and this would be the last one.
No worries.
We're going over time. I don't want to sort of keep you there.
I can talk all night, man. It's fine. So.
But one interesting question was top 5 book recommendations for 20 and 21.
I mean, I assume you're talking about probably data related books, right?
Data related books, indeed.
Okay. Oh, that's a good one. That's a good question. I would definitely say designing data intensive applications, even though this didn't come out in 20 or 21.
Joe, what about your book?
But that doesn't come out until 2022, so that I can't do that.
Sneak peek.
Yeah, sneak peek. Oh, the early release is going to be up in July, so that would be the #1 book I would highly recommend you check out. The drafts. Fundamentals of Data Engineering. It's a great book. You should go check it out. But all seriousness, what was it? It's actually were you reading this one the other day? The Hands-on Machine Learning with Aurelian, because he's actually been shout out to Aurelian. It's actually the #1 book in O'Reilly. He's also been helping out, giving me some tips on writing a book. So that's been a lot of fun. But that's, as I read through that book, that is like one of the best data books I've ever, or technical books I've ever read. Just because of the way he conveys information, he's really fun to read. And he makes that 700 pages or something enjoyable to read. So I think that's a great one. Other books, Data Governance, the Definitive Guide, actually, I think that just came out on O'Reilly like not too long ago, and that one's great too. And just a shout out to my data management peeps. This book, it looks boring as shit. It actually is as well, but it's actually one of the best books that I've read in data ever. It's written by a committee, so that should tell you a lot. But I would say if you wanted context in terms of just like best practices for data, this is actually one of the most underrated hidden gems I've ever seen in data. And this was, I think, last updated 2017. So
the Bible there.
Yeah, right. And then this book I've been reading too, Data Management at Scale. It's pretty good. I don't think I agree with all the elements of it, but I think it's a good book. So
are there any books you've seen that focus specifically on cloud data management?
Quite a few, yeah. And trying to think of the names. Yeah, you stumped me on that one. So, but I'm not lying. I've seen them in the O'Reilly book section there. So, yeah. Let me see. So I just want to answer this. Which are most used, AWS, Snowflake, or know all of them? I think it depends on where you're working. The question is, which would you most use, AWS, Azure, or Snowflake? It totally depends on like where I think you're working. There's not really a right answer for that. I mean, I got clients using all of them. I would say I've seen companies using AWS, Snowflake, and GCP all in the same company because their teams are very distributed and kind of do what they want. They're more of a data mesh type architecture. So, but it's AWS just because of sheer market share, though. Like you can't go wrong knowing AWS. But I would say the most the interesting stuff that I've seen is GCP, actually Google Cloud. They're doing some really cool stuff there. Azure's great, actually. I've done some work there, and I actually am very impressed with what Microsoft's done.
I would say that it irrelevant of which one it is, know one really well.
Yeah.
Because once you know, so for example, like AWS has a very high market share, so just learn how to use AWS. I mean, that's something that I've had to do, that I know other data scientists have done. Know it well enough, and that's the important part, that once you know it, you can then learn the others as you go along based on your use cases.
That's
right?
so true.
So, it's a learning experience. So.
Yeah, it is. And a lot of the fundamentals transfer over. I would say the things that a data scientist should know, or data engineers, like actually the stuff that you probably don't think you need to know. So security, networking, these are all the things that I've seen data scientists get like absolutely like stuck on. It's like, oh, how do I set up the network for this thing? I have no idea. I'll just do it how I think it makes sense. Take the time to read the documentation for the cloud too. Each cloud, and this includes Snowflake, they all have their particular ways of doing stuff. And if you learn how the cloud wants you to do it, that cloud wants you to do stuff, like your life is great. If you try and bring your own opinions about how you should do things in these clouds, I've seen more people get screwed over on this one, and in pretty scary ways, thinking they know how to do security on, bringing their own ideas about security to the cloud. Like that's never a good idea. Understand how they want you to do it and then comply with that. That's one area where, free thoughts probably not like the best idea. So yeah.
Awesome. So I think we can close with that. So
okay.
Thank you so much, Joe, for being here today.
Of course,
Joe,
thank you.
A lot about data engineering and what it is and how to go about learning about it and what are the important aspects of it. So thank you so much for being with us.
Anytime. Thanks for the great meetup. This was a lot of fun. So
yeah, thanks, Joe. We'd love to have you again. That was great.
I'd love to do it again. This has been a lot of fun. So
Awesome. Have a good night. Take care.
All right, take care. Bye, guys.
See you, everybody.
See you.
Thank you for coming.
All right, thanks. All right, see ya.